All right, still a very large group still left, so that's great. Usually we have a little entropy. We've had some, but I'm glad to see so many faces still out in the audience. Very, very, very good. So we have one presentation remaining. I'll introduce them in a moment. Just have a few additional announcements before we begin. First and foremost, we're going to be doing a bunch of raffles at the end. So the most important raffle to me and to WIT and to all of you for future sessions of our BI and Big Data Summit. This is our feedback form. Please fill it out. Of course, wait to the end so you can have a chance to evaluate Donald's presentation as well. But basically what happens is you fill this out, find someone in a blue shirt, trade the form for a ticket, and you'll be entered into our feedback form raffle. We're also going to do a raffle for those of you who tweeted during our session today. And then, of course, the vendors are going to come up and pick their winners out of the fish bowls as well. So please stay around for the raffles. At the end, we are recycling our name tags. So if you'd like to be green and earth conscious, please give it to one of the blue shirts. And we'll be taking care of those. And that is it. So I want to thank everybody for coming out again. But I'd like to introduce Donald Farmer of Qlik. He's going to be talking about the closing remarks and his keynote presentation. Thank you.
Thank you very much. First thing is, am I switched on? Okay, so can you hear me okay? Sounds okay? Good. Thanks. So thank you for having me back here at the Great Lakes BI Summit. It's a couple of years since I've been here. And I think the first year I was here, we'd have filled maybe one of these columns of tables and chairs. So it's fantastic to see this event growing as much as it has. And I'm very honored to be doing the keynote here, particularly at the end. I want to talk to you about not so much about trends and technology, but about some of the problems that I see in BI adoption, which are not technical problems. They're actually more to do with the attitudes that we have towards business intelligence, and attitudes that get in the way of getting the best out of our analytic systems. And one of the principal problems that we have is that we rely too much on conventional wisdom. Conventional wisdom is the explanations that we just generally accept as true. There's a whole bunch of ideas that we go through life with that we never really question. And we have these in our personal lives, we have them in our business lives, we have them in our lives when we're working as BI analysts. And I want to kind of introduce you to a few of these and then try and break down the barriers between us and successful BI adoption as a result. I kind of need to give you some examples of this to let you know what I'm talking about. So let's start with this. The Great Wall of China. Anybody been to the Great Wall of China? Anybody visited? Yeah, quite a few people. Lots of people go to it's one of the key things that you do when you go to Beijing in particular. You go up to Badaling and visit the Great Wall. Well, there's a myth about the Great Wall of China. And the myth is that the Great Wall of China is the only human object that could be seen from space. I mean, we hear this all the time. I still hear people saying this. This is clearly untrue. If you've been to the Great Wall of China, it's very long, but it's not very wide. In fact, it's only about 20, 30 feet wide at the maximum. It's about as wide as one of these tables. If you can see that from space, you can see anything that wide from space. You can see my neighbour's new carport from space. I should have tried that with the zoning committee, you know. It's one of two human objects you can see from space. So it's clearly untrue that, the Great Wall of China can be seen from space. But this is just something that people repeat and repeat and repeat. Africa is about the same size as Greenland. I hear this all the time as well. Now this comes from a very specific problem. It comes from the fact that when you take a sphere and you map it onto a flat surface, then in using Mercator's projection, which is the standard projection because it makes it nice and rectangular, all the spaces get distorted. All the distances get distorted. And this causes some real problems in perception, because it looks as if things which are near the pole are huge and things which are close to the equator are very small. It also completely distorts our sense of distance and direction. I cannot persuade, there is no way I can persuade my father-in-law that British Airways is not ripping him off by flying him 4,000 miles out of his way over Greenland in order to get to Seattle from London. Nothing I can do will persuade him that a straight line between Seattle and London actually goes up near the North Pole. I can use pieces of string on a globe, and yet he still looks at this map and says, no, the straight line doesn't go that way, the straight line goes to New York. This map has become so much part of our view of the world that people simply don't believe any alternative. And this is actually a real problem. It becomes a real problem when we're trying to get aid, when we're trying to provide help to third world countries, most of which, of course, end up clustered around the equator. Because people tend to believe these countries are much smaller than they are in comparison to the distances that we see nearer the pole. So we have this completely distorted view of the world. We assume it must be really easy to get aid to places like Somalia or Ethiopia because they're just tiny little countries. But they're not, they're huge countries. And in fact, transport and the population can be very, very dispersed there. So these conventional wisdoms that we have are not just, they don't just get in the way, they're not just wrong, but they're actually dangerously wrong in many cases and distort our whole view of the world, and as a result distort our attitudes. Here's another one. The worm, the humble worm. If you cut a worm in two, both halves will survive. My mother always told me this when I was doing the gardening chores at home. Don't worry about cutting that worm in two. Both halves will survive. You'll have two worms. If you cut a worm in two, you have one dead worm. It's very comforting to tell children that both halves will wriggle away and become, grow again. It actually isn't true. It's a comforting story that we tell ourselves. Oh, this one. The Vikings wore horned helmets. Everybody believes this. Vikings never wore horned helmets. This is a ceremonial horned helmet from about 800 years before the Vikings. It was never worn in battle. It was used only in religious ceremonies, and it represents, probably some kind of bull god. Has nothing to do with the Vikings. It was invented by Wagner at the time when Wagner wrote his Ring Cycle in the middle of the 19th century because it made them look more fierce. No Viking ever wore a horned helmet. If he did, he'd just get stuck in the trees or, end up tripping over and damaging his colleagues more than he damaged. Probably got a hole in his boat or something, and you never know what would happen. So the Vikings never wore horned helmets, but this is just a story that it happens to fit our image of them. And like so many of these stories, because it fits our image, we carry it forward and we assume it's true. This one, I don't know if you ever heard this one in America, about eating carrots. Do they have this story in America? We certainly have it in Britain. Eating carrots improves your night vision. The more carrots you eat, the more you can see at night. This was a very interesting one because there's actually a film which proves it. There's a film that the British released during the war of British pilots eating carrots so that they would be better able to fly over Germany at night. What they were actually doing was hiding the fact that we'd invented radar that helped us to fly over Germany at night. They said, oh no, it's nothing to do with, it's not a technological advance, it's just because we eat carrots. And I tell you, every child in Britain is brought up believing that if you eat carrots, you can see better at night. I had a friend, and this is actually no joke, I had a friend at school who ate so many carrots, he turned yellow. There's a disease known as carrotonemia. And he ate so many carrots because he wanted to see at night that his skin started to turn yellow and get a form of jaundice. And then he had to have a blood transfusion. No matter how many carrots you eat, you will not see better at night. So anyway, these are the conventional wisdoms that we carry with us in our daily lives. And you can see some of them are funny, some of them are silly, some of them are well-intentioned, some of them come from mistaken representations of the information, like the Mercator projection, and some of them are actually seriously damaging. They get in the way of us making good, well-qualified, well-understood decisions. In business intelligence and in analytics, we have our own conventional wisdom. And just as in the world of our personal lives, that conventional wisdom can be damaging. It can be well-intentioned, but still hold us back. And it gets in the way of us having a realistic representation of the world that enables us to make better informed decisions. And this conventional wisdom, if we can break through it, we can do things differently, and we can do things better. Here's some conventional wisdom. Good reporting is good business intelligence. Good reporting is barely even good reporting, actually. Good reporting, I mean, well, think of what a report is. A report is a representation of a single hypothesis of how the data should be presented to you. In order to design a report, in order to create a report, you need to know exactly what you're doing on screen. You need to know exactly what you're going to show. And you might show sales per quarter, and that's because you've got a hypothesis that showing sales per quarter is important. What you can't do is ask any other questions of the report. If you want to ask any other questions, you've got to get a new report. And therefore, for every question you want to ask, you end up getting more and more reports. And you end up in a situation where you've got thousands of reports on the server, and nobody knows which ones are actually useful anymore. Nobody knows which ones are being used. Or you have a few reports, some of which are continuously used in the company, and they're continuously used because they're the ones we always use. They become conventional wisdom in themselves. Well, this is the report that you must manage because that's the report that we always use for reporting. And this becomes a self-sustaining cycle. A number of times people join new companies and they are presented with, well, this is the report. This is the standard report that you'll get for this scenario. This happened to me when I joined Qlik and when I started leading one of the development teams here. Well, here is our weekly bug report. Now, there was nothing wrong with having a weekly bug report. It was just that nobody had any other insight into the bugs except that one report, because that's the way it had always been done. So, good reporting actually is not good business intelligence. It's just reporting. I like what Richard Feynman said here, that he very early learned the difference between knowing something and knowing the name of something. So often we don't drill into what reports mean, because the report itself gives us the information we're supposed to know. And nobody asks the next question. And the real challenge in business intelligence is how do you ask that next question? Having seen that, for example, sales in the last quarter were down or up, what caused that? Were they down or up in every region? Were they down and up across every product category? You need to be able to ask that next question if you're going to do something about it. And so what you find is that reports provide essentially just description. That's all. In fact, we call it here in this diagram descriptive analytics, and honestly it's not even analytics. It really is just description. Here's what happened. And it's always what happened in the past. It's always something that's already occurred and is done with. The report tells you what happened last week, last month, last quarter, last year, and it's purely descriptive. There's no interrogation, no questioning behind it. It doesn't tell you any diagnosis. What went on? Why were those sales down? What went wrong in France in the third quarter of last year? If you want that information, you won't get it from a report. You only get it by research. You get it by interactive tools. Reports, at the very least, are completely static. One of the first BI projects I ever worked on was in London back in the 90s. And at that time, we were visiting a customer who had very large amounts of data and about 40 or 50 managers in the organization who were responsible for making decisions. And each one of these 40 or 50 managers had 5 or 6 people reporting into them. And they had a really excellent reporting system. It was very good, it was very simple, worked extremely well. It consisted of, remember the green bar tractor paper? Some of you are probably too young to have seen that, but it was like green bar paper with holes down the side. 132 columns by 80 columns, which is 80 times 132, just over like 8,000 kind of spaces on that. And these guys had a report. They said, what we want, Donald, is the way the report is formatted. Could you kind of take out the spaces between the columns? Because we know where all the columns are. Yes, I could do that, yeah. Is it that way we can get more data onto the page? Okay, we can take that out. And then the next request was, this is very good. Can we take out the column headers and the row headers? Because we know what all the columns mean and what all the rows mean. I said, well, yeah, we could take that out too. Good, because then we can squeeze more data onto the report. And then finally they said, and this was enabling, so they said the pound sign, the currency sign, we don't really need that because we know it's all currency. And the decimal point, we don't need the decimal point because we know that it's always going to be 4 numbers, 0.2 numbers. So let's take out the decimal point. That will save us like 15% of space. And let's take out the currency symbol. That'll save us another. We can get so much more data onto this form. And he said, but yeah, but you realize you've got no row headers, you've got no column headers, you've got no currency delimiters, you've got no spaces, you've got no decimal points. All you've got is 8,000 numbers. He said, yeah, that's what we want. Well, how are you going to manage with that? What does that show you? He said, oh, well, it's very simple. Every manager is going to get a card template with a hole cut in it. And every manager's hole will be in a different place. And all they have to do is print out the report, put the card over it, read the number in the hole. And even better than that, we can print instructions around the outside of the hole, telling them what to do if the number is above a certain number or below a certain number. And this was the reporting system. And then they said to us, you know, this is actually really good. Could we do this in, you know, in Excel? Could we do it in Cognos ReportNet? Could we do it in Popkin Architect or something? I mean, they wanted to actually create an electronic version of this. And that system was in some ways very good for giving managers a routine. It was terrible for giving them any kind of diagnostic or insight. The next question beyond description and diagnosis is prediction. And prediction is about what comes next. Now, prediction is a very interesting function when it comes to analytics, because many of us have predictive analytic capabilities which are based on, when we talk about predictive analytics, if I tell you predictive analytics, advanced analytics, you're going to think of advanced algorithmic analysis. How many of you ever have any dealings with Wall Street, or even if it's just by investing stocks yourself and reading about what's going on in the market? Surely most people have done this at some point, yeah? It's a very interesting thing about Wall Street. Wall Street invests probably more than any other business in predictive analytics. Some of the most advanced data analysts in the world work at Wall Street. Some of the most advanced predictive algorithms are developed for Wall Street. Certainly some of the most advanced hardware is used in Wall Street. And yet, how do people make their investment decisions? By reading the reports of investment analysts, which are about sentiment and about their predictions of where they think the market is going to go over the next few months. It's not, you don't just run an algorithm and then invest. It's all driven not only by the technical prediction, but also by the story and the narrative that is built around that. And that is just as important. Despite all their investment in predictive analytics, the human element is still absolutely essential to the way they do their work. And don't pretend for a moment that predictive analytics is capable of doing this on its own. Come back to another myth, that fast in-memory BI, or even better, faster and faster in-memory BI, will fix all your adoption problems. All you really need to do is put something on the desktop, throw memory at it, get the data loaded up in there, have ultra-fast analytics, and everything will happen. And actually, from Qlik, we used to tell this story. 5, 6 years ago, this was Qlik's message. Put it on a desktop, make it fast, everything will happen. The truth is, if you're not careful, you're putting a super fast engine into something which was not designed to take it. You're putting a super fast engine into a vehicle which doesn't have brakes to cope with it, doesn't have steering to cope with it, is about as aerodynamic as a brick. Actually, a guy who lives in our street who's got a car souped up something like this. He's a young kid, he works during the summer, he spends all his money on aerodynamic enhancements for his Toyota Corolla. Which is actually very strange, because then he drives around with the window open and his elbow sticking out, which is about the least aerodynamic thing you could possibly do. But that's just providing the go faster stripes isn't enough. Faster alone doesn't solve the problems. Gartner actually have done quite a lot of research on this, because this is a significant issue for companies, especially companies that invest in this kind of desktop technology. There are really 3 parameters here. There's the speed. Let's assume that everything is fast. There's no excuse nowadays for things not being fast. I mean, in-memory has now become a commodity, if you like, for engines. Almost everybody has an in-memory engine of some sort. So let's assume that everything is fast. If it isn't fast, then that's the first thing to fix. It should be. But then there are tools which are difficult to use, and tools which are easy to use, and tools which are flexible, and tools which are rigid and constrained. Now, no matter how fast your tool is, if it is hard to use and inflexible, all you're going to get is poor adoption. Because you need skilled IT people to build that. You're going to have to build a solution for every problem, because the products aren't flexible enough to answer many questions with one single result. So you end up building the kind of infrastructure that you see when people install massive pre-aggregated data warehouses. No matter how fast they make those, whether they burn them to disk or whether they put them onto really fast in-memory systems, if they're not flexible enough to be modified continuously with the business, then the ROI remains low and the adoption within the business community remains low. If a tool is flexible but still hard to use, what happens is business users can't adopt it. It may actually produce many solutions. It may be easy for the IT department to deploy, may be easy for the IT department to build many solutions with it, but it's not suitable for business users. And what happens here is very simple. If you look at reporting systems today, the number one use of a reporting system is simply export to Excel and do some real work. As soon as you find a report and you want to do something new, export to Excel, and now I can get on with it. The trouble with that is when you've exported to Excel, you've lost any semblance of control or governance or security or any of those things that you originally wanted in the reporting system. If, however, a system is easy to use, well, surely that's a great advantage. Well, not if it's inflexible, not if it's rigid. This is where you get the example of something which is easy to use. It's so simple to create a solution, but the solution only answers one problem. It's not very flexible. What you end up with is thousands of solutions. Everyone can build one. The trouble is not everybody can, not just because everybody can build one, everybody does build one. And so you find customers. There's a customer I worked once with in Connecticut, and this is not an exaggeration. They had 15,000 access databases on a server, all of which had been built by brokers and analysts at that company. And the problem was nobody knew which ones were in use. Nobody knew which ones were important. In fact, it got to the point where the only way the IT department could manage this was to switch off the server and wait to see who complained. The very first complaint came within 2 days. And it came from a secretary in the brokerage department who said, I had the secret Santa list for the Christmas party on that server, and I can't access it anymore. And nobody else had bothered building something. It's incredible. The number of reports and analyses and spreadsheets and databases and things that we build, never to be reused again, never to be looked at again, and yet still living there on a server somewhere with data, sometimes even still being refreshed with no access to it. If you can build a product which is fast, take that for granted, which is easy and simple to use, but is highly flexible, so that the solution you build can be used again and again, can answer not just one question, but the next question and the next question. A tool which is exploratory as well as simple. Now you get high adoption. Now you get a tool which can answer many questions and doesn't need this proliferation of solutions, because each solution itself is powerful enough and flexible enough to give you real insight into what you do. But there's another myth that gets in the way of this, which says, yeah, but I'm not sure we've got the analytic tools in our business to do that. We need specialist analysts. We need people who are experienced in using data. We need people who really understand data systems and analytics in order to do that kind of thing. Just because the tool is easy to use, people don't necessarily understand analytics. And I think this is nonsense, because it comes back to this guy. This guy is difficult to see, but you can see him. If we couldn't see him, we would never survive. If your ancestors couldn't see the snake in the grass, if they couldn't see the tiger in the long grass, if they didn't understand the patterns that occur in nature, we would never have developed and never have survived long enough to be the analytic beings that we are today. We actually have great analytic skills. If only the software spoke to us in terms that enabled us to take advantage of it. We have 4 skills, at the very least, which are innate human skills that are very powerful in data analysis. Pattern recognition, the ability to detect outliers, sorting of data, and categorization and relevance detection. Now, pattern recognition you've seen with the snake. Outlier detection, we do it all the time. What's different? One of these things is not the same. Outlier detection, we learn how to do that basis. Categorization. Categorization is actually fairly sophisticated. It's something we do all the time. And we do it very naturally. Now, categorization, for example, I notice that everybody here is sitting at a chair. Nobody's sitting on the table, which is interesting because what it means is that you've come into the room and you've categorized these objects as chairs and therefore for sitting on. You haven't categorized any of the tables as being for sitting on. That's actually fairly analytic. I mean, believe me, I work for a Swedish company. I go into some of those offices and see that funky modern furniture, and I can't really tell sometimes what the chair is. Sometimes there's more skill involved than you think. But categorization is a basic human skill. We do it all the time. And in business, we're constantly categorizing customers and risks and products and competitors. We're constantly categorizing. It's a skill that we know how to do. There's another myth that all we need are better visualizations. Because we're visual beings. Let us all have better visuals and everything will be explained. That's the only step we need to do. Let's only invest in the visualization tool. That will solve the adoption problem. That will solve the ease of use. It will solve the understanding. There's a couple of problems here, which is non-visual insight is also really important to us. So I'm going to give you 3 words, okay? And one word connects all 3 of these. Can anybody give me a word that connects pine, pie, and sauce? Apple, yeah. Perfect. Apple, you get apple, pineapple, apple pie, and applesauce. Now, that's completely non-visual. That's verbal reasoning. There's no visualization involved in that whatsoever. There's actually quite a lot of forms of reasoning that we do as human beings, which have got nothing to do with our visual instincts at all. And there's a reason it all comes down to brain cells and neurons, the neurons that actually do the processing in your brain. Vision is our dominant sense. But how many neurons do you have in your eye? Absolutely 0. You have no neurons in your eye. It's your brain that makes sense of the world. The visual instinct only helps when you have the cognitive skills, the reasoning skills to make sense of it. I'll give you another example of why visualizations are bad. And again, this is one of my favorite examples. Many of you will have seen this map. If you've done visualization courses, if you've read books by Edward Tufte, maybe you've seen some stuff by Stephen Few or other people, visualization experts. How many of you have seen this? Quite a lot of people. Okay, so this represents Napoleon's march to Russia and his march back. And the big thick brown line is his army marching to Russia. And the width of the line represents the number of troops he had. And the considerably thinner black line is the number of troops he had left marching back. And you can see it was a bit of a disaster. He started off with over 500,000 men. He ended up with basically just a few thousand by the end of this campaign. And this map was created by an excellent French historian called Minard. And many people regard this as one of the best visualizations ever created. Because it shows the number of troops, it shows the route of the march, it shows the battles he fought along the way, and at the bottom it shows the temperature and how important it was that temperature in the Russian winter affected Napoleon's troops. There's a problem with this visualization. Many people say it's the best in the world, and I will tell you, I think it's a beautiful representation of that theory. But it's also possibly one of the worst visualizations ever created, because it only shows you that theory. It gives you no information that could help tell you that Minard was wrong. Imagine a business analysis, a business visualization that only gave you one explanation and didn't give you any information that would help anyone in this room say, but I don't think that's right. I think there's another factor that needs to be brought into consideration. So this is a beautiful representation of one completely biased viewpoint and contains no capabilities of argument or discussion. And to me, that's a disaster. So, and by the way, I happen to show this map because I trained as a historian and I also happen to think it's wrong. I happen to think this is the wrong theory of what went wrong. It wasn't the battles that Napoleon fought that had an influence on the outcome. It was actually the battles that the Russians didn't fight. All the Russians kept running away. And in fact, they ran away so often that the general in charge got sacked. And then they brought in a new general, and as soon as he faced Napoleon, he ran away too. And that turned out to be a fantastic strategy, because it meant that the Russians never got tired out. They lost hardly any men, and also they were occupying territory. Napoleon marched to Russia along a road, and he didn't occupy any territory around either side of the road, with the result that he had no access to food, no access to water, no access even to shelter for his men and horses. So of course they were worn down by the weather, but it wasn't because the weather was bad, it was because he was completely badly provisioned. When the Germans did the same over a century later, they made sure that they occupied vast areas of territory in order to be able to get access to food and water and so on. So this map is a great visualization of an error, and it doesn't include any alternatives. From that point of view, if you came to me with this as an explanation of a business strategy, you'd potentially be misleading me and your board and anyone else who is making decisions on the basis of this information, and you wouldn't be giving them the context necessary to explain why it isn't so. Let me show you another one, also very, very popular in the world of data visualization. Just as bad. This one's also very popular. Anybody know what this map is? Okay, this is a map. Somebody knows it back. Somebody's been on the course. This is a map made by a doctor called John Snow, who was investigating a cholera outbreak in London. And every dot on this map is an outbreak of cholera. And in the middle of this outbreak, and you can see how it's all clustered together, there was a well. And they took the handle off that well, and the cholera outbreak stopped. And this is the story. And then we're told how an amazing visualization this is of this map, because it proved that it was the well that was causing cholera, and cholera wasn't drifting in the air, what they call the miasmic theory of disease. But cholera instead was actually being passed by the water supply. There's two problems with this map. The first is that it did no such thing. People still believed in the miasmic theory 50 years after this map was drawn. It didn't persuade anyone. They actually remodeled all the streets of London around here in order to improve the airflow, because they still believed that it was passed by air. Florence Nightingale, very famously, used to get people in her hospitals to open all the windows, because even in her age, they believed that disease was caused by air. And so to open up the windows and improve the airflow was important. So he didn't persuade anyone. It's not a persuasive visualization. And the other problem with this visualization is it wasn't used to solve the problem. It's a representation of the data after the problem had been solved. John Snow did not use this map to discover that cholera was spread by the water. He discovered that by talking to people, by walking around the streets and gathering the information. The visualization solved nothing. So in both these cases, the visualization is not persuasive enough, is not correct enough, and didn't actually solve the problems that we now believe it solved. It's become conventional wisdom that these are great visualizations, and they just aren't. Another myth, that better access to data is going to improve your decision making. Oh, would that were true. All we need to do is give everyone more and more data, and decisions will magically get better. That is not the case. We know what helps decision making. It is iteration. It's improving the number of times we look at information and share it. It's practice. Practice is really important. How many of you practice data analysis? How many of you practice investigating problems in your data, or practice investigating problems in your business? So one of my favorite customers was a cosmetics company, is a cosmetics company. And they had a dramatic issue in their business after the tsunami and earthquake in Japan, because essentially the Japanese market closed down for them. Now this wasn't just a human tragedy, but for them in business terms, Japan was one of their largest markets in the world, and it basically just closed down overnight. There were two effects of that. First of all, of course, there was a dramatic effect on their sales, but there was another effect that nobody had anticipated. Japan was actually a supplier of a very small quantity of very, very valuable ingredients. Highly processed seaweeds, purified earths that were used in various cosmetics that they were making. And now those supplies were no longer available. And that was a particular problem for a new product line which was about to be launched in Australia in 3 months' time. And they already had the magazine space and the television space. They already had the supermodels lined up for the adverts, and there was going to be no product. So they had to cancel their product launch because there was going to be no product to launch. Now, the only reason they were able to make that discovery, the only reason they were able to find those problems, was because that company relentlessly practices discovery. You go into that company's offices and they have two whiteboards on either side of the data analysis kind of cubicle area. One whiteboard is new discoveries made, in our case using Qlik, but using their software, new discoveries made by interest. What's the most interesting discovery somebody has made this week in the data? And on the other side, there's a whiteboard which is the most valuable discovery in monetary terms that people have made. And to have your name up on that board is a big thing. And to have your name up on that board at the end of the year results in not only recognition, but some reward as well. And this encourages people to play with the data. They want to make discoveries. There's a reason why in your offices you have fire alarm drills. It's so that when the fire alarm really goes off, you know how to get out of the building. Imagine if they waited until there was a fire and they said, well, by the way, this is now how you get out. It's not really going to work. You have to practice it. In the same way, this company practiced, how do I discover things in my data? If they had waited till 20% of the world economy had closed down on them and then said, oh, we better start looking to see what's in the data, they would not be so effective at doing it. So I'm going to ask you, how many of you play with your data and investigate and sharpen those analytic skills every day, just because, not because you think you're going to find anything, but to see what's there? And I'm pretty sure I know the answer. You'll be like, well, one hand goes up. Excellent, I'm glad to see it. You don't work, we can ask who you work for later on. You don't work for a cosmetics company, do you? No. But it's amazing to me, people don't practice data analysis. You know, there's a reason cats play with mice when they catch them. It seems very cruel, but it does two things. First of all, it means that some of the mice escape. And that means that the cats don't kill all their prey, therefore they'll survive better. But the other thing it means is the cat has sharpened its hunting skills without actually killing anything. And so when it does come to the time when the cat really has to catch something, it's got those skills in place. That's why we play. You need to play with your data. It's iteration. It's not just having the data, it's using it. And don't wait for the emergency before you use the data. So, my summary, in a sense, is we're held back by the conventional wisdom. We're held back completely by convention. You have to break through some of these things. In particular, if you're going to look for ROI and adoption, you've got to get out of this idea that it's just about showing you what you already know. It's not about reporting, it's about diagnosis and understanding. Yes, you can do high performance work within memory, but you better have flexibility and ease of use as well. And the flexibility means you don't need to build thousands of solutions. You can build single dashboards, single apps, which are exploratory. And exploration is absolutely critical. Visualization is not enough. In fact, visualization can be deeply and profoundly misleading unless it is tied in with narrative and discussion and debate. And a visualization is used to lock out debate. If it's used only to give you the view of information that the visualization expert thinks is important, then it's doing your business hard rather than providing value. What you need is to nurture the natural analytic talent that your business users have. And you can do that by giving them space and opportunity and the tools that help them to practice, to literally play with the information. Because you cannot wait until you need to get it right in order to get it right. So I want to leave you with that thought. I want to leave you with the thought that you should challenge the conventions. Go back to your organizations and see what is the conventional wisdom in your organization. Is it holding you back, or is it helping you to move forward? And my challenge to you is to find space and time and the right tools to play and debate and to investigate and to explore. And I think if you do that, you'll bring tremendous value to your organizations, more than any single deployment of any single technology. Playing and debating and exploring. And you know what? It's great fun as well. And that's maybe one of the better benefits of it. Thank you very much for your time. I hope you've had a fantastic day here.
All right, thank you, Donald.
Thank you.
All right, so we are going to be doing the closing raffles. Again, this is the sign-up sheet to let us know how we can do better. Let us know what we did great. Appreciate it if you fill those out. So fill these out, trade them for a ticket, and hand them to a blue shirt.
Good.
Take 1 minute or less to thank all of our wonderful sponsors for coming out today and sharing all of their wisdom. So applause for our sponsors, please. All right, so first we've got Donna from Qlik is going to be drawing their gift.
Jim Madsen from Ford Motor Company. Very good. Oh, you forgot to bring the gift. I'm going to go get it.
All right, so our annual convention that I should have mentioned earlier is that you must be present to win. Yeah. Okay? All right, so good deal. All right, all tricks.
All right. Nell Welch. Nell Welch? Huh? Azar Ahmad? It's a Fitbit, so
All right, Informatica.
the gift receipt's in there. Come on, guys.
All right, thank you.
Yeah, thanks a lot.
Mr. Fire.
Going once.
Okay, let's see. We got Dennis Rowe from Telegration.
Dennis Rao, Telegration.
Are you
All
here?
right.
We have a winner.
Kalpana Nagorigan, Ford Motor Company.
All right, information voters.
Thank you.
Enjoy.
Alexi Antonio from Qlik.
And last but not least, Tableau.
Where are we going shopping?
Sudhir Handy from Ford.
Congratulations. All right, so two more raffles. All right, first one is the Twitter raffle, and as my comrade here, I want to thank Amanda Mansour, who was really our quarterback for this entire event. Thanks, Amanda. All right. Oh, double winner.
Oh,
Azhar Ahmed.
you want to get it?
I think that's a BI Summit first.
Yeah, it really is. It's never happened before. Congratulations.
Thank you. Thank you.
Has everyone submitted their feedback form?
Forms are in, tickets are out. Glasses required. And I got to hold it away from me. 863-346. 863-346. They must have left. Anybody? Last call, 863-346. 863-264.